Hello, fellow foodies. You're listening to Foodie Pharmacology, the science podcast for the food curious. On this episode, we're going to explore the concept of crop diversity, why it's important, and what it means for the future of food on Earth. I'm thrilled to have a very special guest on the show to discuss this topic. Dr. Cary Fowler is an agriculturalist and former executive director of the Crop Trust, whose mission is to ensure the conservation and availability of crop diversity for food security worldwide. Dr. Fowler is best known for his work with the Svalbard Global Seed Vault, sometimes called the Doomsday Vault in the media. His work was the subject of a 2013 documentary film entitled Seeds of Time, and his book, Seeds on Ice, Svalbard and the Global Seed Vault, describes the efforts to conserve crop biodiversity before it's too late. Thanks so much for coming onto the show, Cary. It's such an honor to speak with you today.
Thanks, Cassandra. I'm happy to be with you.
Great. Well, to start off, why don't we just begin with some of the basics, like what is crop diversity?
Well, I think the best way to answer that question is to say that crop diversity is actually two different things. One is something that we're all really familiar with, and that is that there are tomatoes and there's broccoli and there's wheat and there are oranges and apples. That's crop diversity. But what we very often don't see, or we just see the tip of the iceberg of, would be the diversity within those types of crops, that there are many different kinds of apples, and of course, we see a few of those in the grocery store, but there are also many different kinds of wheat. Those are not so readily visible in the grocery store. And in terms of order of magnitude, there is more diversity out there than you can imagine within our different crops.
Yeah. So when we talk about the diversity within one's crop species, how much difference can there really be between different types of apples? Like, where do we, is it in the flavor or the chemistry? Where's the difference?
Well, it's everywhere. I have an orchard here on the farm that has, over 100 different varieties of apples. So if I walk down the row of apple trees, I see apples that are very light in color, and I see some that are really approaching black. So there's very, very deep purple. And if you cut them open, some are kind of ivory in color, and others are actually red inside and sort of in between. And those are visible things. But I can also see that the pests, the insects, like to munch on some varieties more than they like others. Mm-hmm. The tastes are really, really different. The production level of each variety is different. And the purposes that they've been saved and developed for over the years, those are different too. When I was growing up and spending time with my grandmother in Tennessee, she would tell me which varieties were good for just eating out of hand and which I shouldn't be eating, though of course I was a kid and I didn't obey her. But she would tell me I shouldn't eat them because they would give me a stomach ache and they were going to go in a jam or jelly.
Uh-huh.
So there are a lot of differences, like that. But I think that many of those differences are very important to us that are invisible. There's a Colville Blanc apple which is a delicious French variety that I grow, and it's reputed to have something like 8 times the vitamin C of a Golden Delicious apple.
Wow.
So, when you think about the old adage that an apple a day keeps the doctor away, really got to specify which kind of apple to know whether it's an apple a day or it's 8 apples a day. Right?
That's a really great point. Yeah. And when you think about how did all of these varieties of apples come about? We know that apples originated, I believe, in the area we know today as Kazakhstan, but how do we have so many varieties today?
Well, we have them because of our ancestors and our friend the bees. And apples don't reproduce true to form. So if you take a Golden Delicious apple, for example, and you plant the seeds, you're not going to get a Golden Delicious apple out of it. What you're going to get is an apple whose mother was Golden Delicious, but whose father, only the bee knows.
Okay, that's great.
He's not talking. She's not talking. Um, so there's been a lot of diversity, shuffling of genes back and forth between these different apples over the years. And people would watch, and maybe an apple tree would grow up in the fence row where it wouldn't get cut down so easily. And if it tasted really good, what happened then? Well, the people would graft it, would take a little cutting and graft it onto another apple tree. And that's how you preserve apple varieties. So in other words, there was an original golden delicious apple, and there was an original Arkansas black apple or Roxbury russet, the first American variety. And that's how that's done. But for most of our crops, like the seed-bearing crops, the grains, the vegetables, and all that, all of our crops have really co-evolved with us as human beings. And our ancestors saved protected, defended, conserved, saved for seed the next year, the varieties, the types that they really liked. And they were handed down to us. This is a real inheritance that we've gotten throughout the history of agriculture, which is, depending on how you count it, some 12 to 15,000 years old.
Yeah.
Let me give you an example of that, which I think is one of the coolest I've ever known about. One of my heroes in this field, my real hero in this field and mentor, was a man named Jack Harlan. And he was a professor at the University of Illinois. And I think when he died, he probably knew more about crop diversity than anybody ever had known about it. He was an expert in sorghum, which is a grain crop originated in Africa. You make molasses out of it. It's going to be really important in climate change adaptation, I believe. Anyway, he was in a field in Africa, and he came across this field of sorghum. And most sorghum, it can kind of look like corn, like maize, growing on a straight stalk. But this sorghum didn't grow on a straight stalk. It grew on a stalk that started out straight and then made a curve and then went up again. And he looked at it, he could not figure out what kind of adaptation this was for. Why would sorghum develop this way? And why would a farmer save this crook-necked sorghum?
Yeah.
And he asked the farmer about that, and the farmer smiled and said, well, let me show you. And the farmer took him to his little hut. Now, when you harvest sorghum, which the birds like a lot, you've got to get it out of the field and you've got to dry it someplace that's protected from the birds. Well, most people would harvest their sorghum and they'd tie up each individual stalk and tie it up to dry in their homes. But this man had developed sorghum that came sort of like a coat hanger. So he could erect a single piece of rope across his room and just hook it over.
Wow.
So much labor, which I thought was incredibly ingenious, but it kind of shows you how we have co-evolved with plants, and the diversity we see is a reflection of our taste and desires and needs. And that gets translated into different varieties.
That's amazing, and it really speaks to the ingenuity of traditional farmers across the globe. I've done a good bit of field work in the Balkans. In my last trip to Albania, I noted there's a very special kind of local rye variety that has a very long stalk. And what they do is they use that stalk for their thatch roofing. And unfortunately, now that they're moving more and more to metal roofs, fewer and fewer people are growing that variety. And so these types of varieties come and go with the ebb of utility in different groups, I would guess. Yeah.
Yeah, and sometimes when you wonder why farmers in developing countries don't grow the most modern variety and the one that's the most highest, the highest yielding variety, it might be because they see maize or wheat or whatever in a more nuanced way, and that they want varieties that are that will yield plant material that they can feed to their animals. So it's an all-around kind of thing. And they also might be, typically are in developing countries, growing a mixture in their fields, not just a uniform variety, because if you're a small subsistence farmer, for instance, you don't want all your eggs in one basket. You want to hedge your bets, and you hedge your bets by having different varieties that may mature at different times of the year and have different levels of pest and disease resistance, et cetera, et cetera. So
Yeah.
Typically there's a lot of diversity in developing farmers' fields.
That's great. And that's in such contrast, though, to industrial agriculture, right? So we have huge diversity in these smaller scale farms. Tell us a bit about how that differs from larger scale ag, and how has the transition to larger scale ag put some limitations on the maintenance of these different diverse varieties?
Well, I think if you look at those different kinds of farms, let's say a small scale, somewhat subsistence level farm in a developing country and a larger industrial kind of farm in the United States, if you look at that through the lens of crop diversity, both of them actually have a lot of diversity, but one is diversity in place and one is diversity in time. The diversity in place is the developing country farmer that has a lot of different types of a particular crop in his or her field, whereas the farmer in Iowa, for instance, has diversity in time. All the corn in that field is going to be exactly the same. It's going to be uniform this year. But that farmer might have a completely different variety next year.
That's a really good point. Yeah.
So when you're thinking about, well, what's the role of a variety? It's to be appropriate in any given place and time. And those conditions change. So it might be that in some circumstances, the diversity in place is very much appropriate. In others, the diversity in time is the way to look at it.
Yeah, that's a great point.
So I try, I'm not a fundamentalist on these kinds of things. People sometimes want to say, well, one system is good and the other system is bad. And I sort of trust the farmers a little bit more than that. And I also try to be humble about this, not knowing what kind of system is going to be best in the future. And I sort of think, well, we're going to have a mixed agricultural system in this world for a long, long time. And it's best to try to prepare all of those farmers, no matter what kind of agriculture they're practicing, for the future.
That's so important. Well, especially when you think about the future with climate change, where do you see the role of crop diversity and climate change, and how do we reinforce a source of resiliency in our food system for the future?
I think climate change poses the single most daunting challenge that agriculture has really ever faced. And it comes at a time when we are facing a few other challenges that I'll just throw into the mix. We're looking at shortages of some nutrients like phosphorus. We're probably going to hit peak phosphorus production. That's an essential element in agriculture. We're going to hit that by the end of the century, if not earlier. We're certainly going to face water shortages in particular areas. We know that a lot of the aquifers are not being replenished, so we're taking down the water level there. And then there's, of course, climate change. And climate, in July, I think we had our 428, something like that, consecutive month where the average global temperature for that month exceeded the 20th century average for that month. That's a lot of coincidence. 420 something straight months of above average temperatures. And, many people will say, well, so what? But you can't say that when it comes to agricultural crops that are adapted for a particular climate, environmental regime. And what climate change does is it doesn't just change the average temperature for the year or the month. We have longer periods of hot weather. We have higher extremes of hot weather. We have hot weather when we really can't handle hot weather, such as when a particular plant is flowering and setting seed, in other words, the crop, the food. And we also are finding that many species are migrating. They're on the move. Thousands of pests and diseases are on the move. So when you think about it, we are entering into an incredible agricultural experiment. We are throwing together species, bugs, pests, diseases, and our food crops. We're throwing them together in new mixtures that have never before lived together in our agricultural history. Now, you could say, well, I would say, I think we're going to get some surprises. And maybe not all those surprises will be good surprises. So we have to prepare for those surprises. And essentially, how do we prepare for those? Well, we prepare by helping our crops prepare for them. Okay. And how do they prepare? Well, we got one of two solutions there that we've been practicing lately. One is to try to modify the environment, but my gosh, we seem to already be doing that.
Yeah.
It's not helping us too much. Of course, we could try to do it further, but when the well runs dry, irrigation systems don't work. So the other way of doing it is to try to breed new crop varieties that are adapted to situations of higher temperature, of needing less water, et cetera, et cetera. And that's where crop diversity comes in handy, because those kinds of traits that you want in your crops in the future, those traits don't fall down out of the sky from the heavens. They actually exist in the gene banks, the seed banks around the world, if we're smart enough to save that diversity.
Yeah. So let's talk a bit about these gene banks and these collections, because these really represent centuries, if not millennia, of agricultural advances that you're really saving. And so how do you go about this in practical terms? How does one seed bank?
Mm-hmm. Well, the first collections that were made in a serious way were made in the 19-teens or early 1920s by a Russian scientist named Nikolai Vavilov. And essentially what's happened since then is what he was doing. He was going all around the world to what he called centers of origin of our agricultural crops. They were really centers of diversity, which happened in most cases to be where the crop actually originated, and over time, in that coevolution with human beings that I spoke about, developed a lot of diversity. And he was collecting seed, bringing it back in those days to St. Petersburg, Leningrad, and was essentially freezing it or keeping it very cold. And today, still scientists occasionally will go out and collect materials, diversity in the field, some new type that they have come across. And if you want to conserve that diversity long term, well, it can get complicated, but down to the simple facts. You want to dry it so that the seed has not so much moisture in it, and that reduces the biological activity inside the seed. And then you freeze it. And all that slows down the aging process. And most of our crop seeds can be conserved, will remain viable for many, many years if they're stored properly. So that's the task of, how you get the seed in the seed bank. But the seed bank doesn't exist because we just love diversity and like the idea that something is not going to become extinct. I must admit, I have those feelings myself.
Yes.
So I totally understand. But the purpose of the seed bank really is to provide plant breeding materials for the plant breeder, who for most crops is functioning like the honeybee, is going to move pollen from one variety to another, is going to be responsible for who the daddy is, who the mother is, and is going to create a new variety. And what you want, of course, particularly in in an era of climate change, or just frankly in an era where we seem to be having a lot of bad weather, you want that plant breeder of tomatoes or wheat or corn or whatever to have access to as much diversity as possible, because that diversity represents the options that we're going to have for the future. And that's really why seed banks are there. It's to help researchers breed new varieties of crops, and also do basic biological research on all these different things.
That's great. And Cary, how many different seed banks are there roughly around the world? I mean, are there just a few large ones, or are there many smaller ones in different countries?
Well, there are a lot. There are a lot of institutions around the world that are banking seeds. But some of those have maybe one sample of one crop or something, and not serious. If you counted all of those, it might be 1,300. But I think there are probably only about 75 or so that can provide what I would think of as secure long-term conservation services.
That's great.
So if you took, I don't know, the top 25% of the seed banks in the world, at the lower end of that range, you would be dealing with a national seed bank of about 2,000 samples, which might sound like a lot to a gardener, but for a nation like Trinidad or Cameroon or something that has a seed bank of that size, it's a very small collection, and probably not a collection that would lend itself to a terribly serious plant breeding program. And I think, if you don't mind my adding in, I think it's important to note that countries are really interdependent in terms of the crop diversity they need. The United States has a fantastic national seed bank and some satellite seed banks around the country. The national one is located in Fort Collins, Colorado, on the campus of Colorado State, and it has about 500,000 samples of seeds. But if you look at, well, how much of the global total does the United States have, it's a much smaller amount. And if you look crop by crop, there are really few, if any, crops where we have 10% of the global total. So that's not an exact correlation with how much diversity there is, but it's a little bit of a surrogate. And so if you were looking at a drastically changing climate, or you were looking at trying to breed resistance to an insect, and that resistance wasn't easy to find in our gene bank collections, if you were a plant breeder and you said, well, the United States has 5% of the total samples in the world of this crop, you would, I'm sure, be happy if you could have access to the other 95%.
Yeah.
And what
more options.
Yeah. So, what that means is that as good and as big as our collections are, the future of our American agricultural system really rests on not going it alone, but actually forging cooperative links with other countries and sharing this, which, it's a common heritage of mankind. Is there anything that's more of a common heritage than this?
In our food systems, yeah.
So I think it behooves us to learn how to share and do it really well.
That's great. Well, in addition to this, the genetic information in the seeds themselves, what other types of information is included in these gene banks? Are there records of known pest resistance, or records that show this one is this tall, or this one's this tall at full maturity? Like, what other kind of ancillary data is present in these gene banks?
Well, there should be a lot, but sometimes there's not. It's really been in my lifetime, I think, that scientists have, in fact, my professional lifetime, that scientists have begun to understand that it's really important to, for example, interview the farmer whose field you've just gotten seeds from, to ask them, well, why do you grow this particular variety and what can you tell me about it? I remember walking off the road in Ethiopia one time for about 45 minutes to get to a little village where we had heard that there were some very different kinds of sorghums, actually. And I was with the head of the Ethiopian Gene Bank, who was a sorghum expert, had gotten his PhD in the United States on that crop. And we got there. This is a village without electricity or running water, and they had their sorghum seeds stored in a very huge basket bin, 4 or 5 feet tall. We took off the top of it, looked in there, and my friend was rather disappointed. And he said to one of the local villagers, I thought, I heard that you had a lot of diversity here. I don't see, and he picked up seeds in his hand, and he said, I don't see any diversity. And the farmer looked at him like, are you crazy? And he began to point out individual seeds, and he said, look, they're different types. They're different types in here, and began to explain to us how the different types were used in a mixture in the field. So, ideally we have a lot of information about the growing habits, how you cultivate it, the use, the nutrition, the pest and disease qualities of all the samples. And we have an information system that's computerized that can help sort that out. But that's still sort of to be developed, and we still are far away from that. When I worked at the Global Crop Diversity Trust, we had a partnership with the U.S. Department of Agriculture to develop a global information system. And, there were skeptics about why do we need such a thing if we have such a great seed bank in the United States. And I said, well, what if the disease or pest resistance we need is only to be found in the Polish gene bank? Well, we get it from Poland. Well, how do you know it's there? If you go online, the database is in Polish.
Yeah.
And ditto many other languages around the world. So we've tried to create a global database system that would help researchers find what they really need. But if you don't have that, you're just it's just pot luck, and then you're just conserving it without a potential use.
Yeah. Well, and as an ethnobotanist, my entire field, all of my colleagues are dedicated to the study of the relationships between humans and plants. And this is, I think, a space where ethnobotanists could make a big contribution, working with and in concert with local communities to document these exact types of things, along with collecting the genetic information. Yeah.
It's absolutely true. It's a great field of study. I love it.
Great. Well, I want to dive into one of your greatest passions, and that's the Svalbard seed bank. And as I mentioned before we jumped on the call, is I show my students Seeds of Time every year. I teach a course called Food, Health, and Society. And I love the way that the documentary takes you on a journey to understand the challenges of seed banking and also the urgency behind it. And I was wondering if you could just give us a bit of the backstory of kind of what led to its creation and where do you think it's going to play a role in the future?
Sure. Well, I spent most of my professional career, such as it's been, working around these issues of crop diversity, both in an NGO. I worked in a university, I worked for the United Nations, I've done a lot of different things, but all centered around trying to conserve this diversity. I worked for some years with a group called the Consultative Group on International Agricultural Research, and that group is a consortium of agricultural research institutions that operate 11 major international seed banks. And this is, this is almost the first stop for most plant breeders and researchers. They go to these collections first because they're so well documented and the material really is accessible. They'll send you good seed. The problem originally was that these institutions didn't have any call on a tax basis. They were international, so they couldn't lobby their Congress for money that they needed to replace the equipment that was dying or whatever.
Like freezers and things like that, right? Very important to keep seeds cold.
It's pretty simple, but the freezer needs to be on and functioning. Yeah. So, through the World Bank and others, we got a large grant to upgrade these facilities and really bring them into the modern world and make sure everything was working properly. And at the end of that, we were pretty happy about the situation for these major and critical collections. However, they were located in countries that many of which had recently experienced war or civil strife or were about to. So they were in Colombia and Peru and Syria and Nigeria and Philippines. And about the same time, we, all of us experienced Hurricane Katrina, and we experienced 9/11. And a man named Henry Shands, who was the head of the U.S. Gene Bank at that time, and I were sitting around. We had been involved in this project to upgrade these big international gene banks. And we realized that what we had done simply wasn't good enough. It didn't really secure these collections because the collections were still in buildings. And everything that's bad that can happen to a building can happen to a seed bank. Yeah. And probably has. I could tell you stories about that. And then we really thought about Hurricane Katrina, and I remember thinking that that the experts were really excoriated after Hurricane Katrina because obviously they knew that sooner or later a Category 5 hurricane would hit New Orleans, and they knew that the levees wouldn't hold, and it'd be a huge disaster. So why didn't they do something? Yeah. The they being the experts, as if experts have that much power, but nevertheless.
Power and money to fix everything, yeah.
Those things don't come together. So not with the experts. So we realized that in this situation, the they was us. We were the experts that realized that something was almost going to be inevitable that something really bad would happen to a gene bank. And since much of this material, the diversity stored there, hadn't been safely duplicated anywhere, we would face an extinction event. We could face an extinction event regarding, for example, a major collection of rice or wheat that potentially would have the genes, the diversity in it, the traits that would prove critical to the survival of that crop in the future. Well, this was not a situation that was tolerable. We had to do something about it. And long story short, we ended up approaching Norway to see if they would consider having such a building and maintaining such a facility in the far north, 78 degrees north, near the North Pole. The reason we approached Norway with a couple of different things. One was the Nordic Gene Bank, Sweden, Norway, Finland, Denmark, they had actually put some seeds up there in an abandoned shaft of a coal mine, a little bit as a backup and a little bit as an experiment. So seeds in Svalbard had some connection in the minds of some of the Nordic people. The second was that Norway was a very trusted country. And so we thought that if any country in the world was going to host the largest collections of seeds in a very suspicious conspiracy oriented kind of world, it might be Norway.
Yeah.
And I had an appointment at that time as a professor at a university in Norway, so I knew some of the major players in the government and in agriculture in Norway. So the stars were aligned, and we approached Norway. And it was one of those situations where if you raise your head up a little bit too high, or ask a certain kind of question, you get appointed to be the head of that committee.
Yeah.
So we asked Norway if they could assess the feasibility of establishing a seed vault in Norway, in Svalbard, and they turned around and said, well, actually what they said was, they called me up on the phone. They said, do you know the answer to your question? Is it feasible? I said, no, I really don't know the answer to it. And the guy on the other end of the phone said, good, you're going to be the committee chairman. So they appointed me the chair to make that feasibility study. And I said, who else is on the committee? And they said, you pick them. So Henry Shands, the guy I mentioned a few minutes ago, of course, he had to be in there. We were co-conspirators at that point, and we assessed the feasibility, and we tried to do as good a job as we could because they knew where we lived. So.
And now today, Cary, how many countries have contributed to that seed bank? Are there crops from all over the world now present?
Yeah, there are. I think the number of institutions that have contributed is over 80. The seeds themselves have come from, 140 or so countries, including some countries that no longer exist. So, for instance, any major seed collection is going to have seeds from all over the world, like the United States. We're the home. The United States is the native home of very, very few crops, none of the big, important cash crops. So our researchers have been collecting all over the world for a long time. And of course, that is now safety duplicated in Svalbard. So we now have in the seed vault a bit over 1 million samples of different crops, and that would include, I think, around 150,000 different types of rice and 150,000 different kinds of wheat, and tens of thousands of beans, and et cetera, et cetera. Mm-hmm. And by the way, these samples are not samples of genetically uniform varieties, like you might go to your garden center and buy a packet of a certain kind of tomato or something. These are samples of that diversity that I was describing earlier that could be found in a developing country farm. So it is really, even to think of it as 1 million samples of 1 million different kinds of crops is actually kind of underestimating the amount of diversity that's really in there.
Yeah. And so how did it get the Doomsday moniker?
Well, somebody, and I don't know who it is, actually, maybe it was a headline writer for a magazine called The New Scientist. Nobody had ever paid any attention to what people in my field were doing, and but a fellow that I knew named Fred Pierce, who's a great science writer, would call me up once or twice a year and I think sort of yawn a little bit and say, Cary, anything interesting going on in your field that I should know about? And one year, I was able to say, well, it's sort of interesting. We're going to build this facility in Norway to have a backup of all the major collections. So if something bad happens in a seed bank, it doesn't mean extinction. Oh, well, that's kind of interesting. I think I'll write something. And there was a small article in the New Scientist. And I believe that was where a headline writer came in. And I believe the headline had something like Doomsday Vault opens in Arctic.
Sounds like a movie title.
I learned two things from that. I learned one is that the media reads the media. Yeah. where does the media find out about things? Well, they read other media people.
Yeah,
And so all of a sudden the phone was ringing off the hook sort of, and people wanted to know about it. And then, of course, the second thing I learned was that if you go close to the North Pole and put something inside of a mountain where people can't see it, it'll generate a lot of conspiracy theories. So
yeah.
pretty hard to prove the negative of what's not happening there.
Yeah. Such an important collection, though. And I seem to recall a few years ago that there was actually an accession that had to be made from the vault. Was it an accession from Syrian wheat, maybe? Yeah. Can you tell us about that?
Yeah, sure. Well, when we opened up the facility, the Seed Vault opened in February of 2008. And we had on opening day 100, 200,000 samples go in. Of course, we had been planning this for a long time. At that point, I thought, boy, this is a success. If we just can ensure against extinction that amount, it's all been worth it, even though, of course, we've now exceeded 1 million. And in the very beginning, I had a friend who was the head of a research institution, one of these big international ones that was located just outside of Aleppo, Syria, and Arab Spring was starting. And I spoke with him about that. And I said, we need to get a duplicate copy of your seeds up to Svalbard. And he agreed, but there was no particular urgency, because this Arab Spring thing that was in Libya and might, if you really think about it, might go to Egypt or something, would never get to Syria. There would never be any trouble in Syria because the regime was so powerful and had so much control. I said, well, just in case, why don't we move on this? And I'll never forget, he kind of laughed and he said, just in case. He said, isn't that what the Seed Vault is all about?
Gives me chills to think about. Wow.
And I said, yeah, the Seed Vault is all about just in case. And that was one of the major collections in the world of wheat, barley, lentils, chickpea, and a crop I really like called grass pea, which I'm growing out in my garden right now. And particularly valuable in terms of the collection being geared towards drought-tolerant varieties, heat-tolerant varieties. So we began to get that collection out, and Arab Spring, of course, spread a lot faster than he or I would have predicted. And in the very last days before fighting erupted in and around Aleppo, and now you can even go on YouTube and see pictures of soldiers or rebels or whoever they are with automatic rifles in front of the main administration building, celebrating taking it over and looting. We got the last of the seeds out just in time. But I will mention that the international scientists at that institution had to flee, of course. They wouldn't have been safe. The local people, the local staff didn't have any place to flee, really. And there are some incredible heroes there locally who maintained that seed bank when everybody else had run away. And that's kind of the story, a recurring story, I have to say, in this whole field of crop diversity, of people actually understanding that this resource is so important to food security and our future life on this planet, that they've been willing to give up their own lives to save it, even though the vast, population in the world would never understand why it was important to do that. But there have been scientists that have been willing to do it, and local staff.
It makes me think of going back to Vavilovs' story, and can you just recount us with a bit? How did he die? And I know his staff, did they starved, right, to death, surrounded by seed?
They did. He had assembled the first major collections in the world, and he used them for basic biological research, not just crop breeding, but he was the one that began to really identify where in the world our different crops came from and where you could find the most diversity of each crop. If you want to find the diversity of beans, you don't go to China or Thailand or something. You go to Central America and South America where beans originated. Mm-hmm. And the same applies to all the other crops. So he went all around the world collecting it, brought it back to Russia in the seed bank that he constructed there. And he had just actually gotten elected, I think, the president of the International Genetics Society, whatever the association. But then Stalin was over the Soviet Union at that point, and Stalin wasn't, let's say, a big believer in genetics. Stalin was under the influence of a scientist named Lysenko, who believed in the inheritance of acquired characteristics. That's a longer story, but the Nazis surrounded St. Petersburg, Leningrad in those days, and bombarded it for 900 and something days. And people in the city were starving to death. Mm-hmm. There are incredible tales. I could tell you a number of people in this institute trying to preserve these seeds. Vavilov himself was arrested as being an enemy of the state. Why? Because he was a geneticist and a famous one at that time. And he actually died of starvation in prison towards the end of the war. But his staff carried on. And in December of 43 or 44, I forget, I think about a dozen people or so on his staff actually succumbed basically to starvation. And the curator of the rice collection, I think his name was Ivanov, died sitting at his desk, piled high with bags of rice. I mean, obviously he could have eaten that rice and survived. And when I made my first trip there in 1985, they were preparing for a centenary, a celebration of Vavilov. And I was trying to get some kind of feel, some notion for what was going on in this building, you know, as these people were surrounded by the Nazis, pulling shifts standing on the roof so that if bombs fell around and embers fell on the roof, it wouldn't burn the building down. It was cold. They were hungry. What was going on in their mind as their fellow scientists starved to death? And why did they do it? And the woman who was putting it together, who knew some of these people, the staff that had survived, she said, well, we were students of Vavilov. And we thought that the world was going up in flames. And what we were protecting here would be necessary for reestablishing civilization after this war. Well, it's not actually a stretch. And that's what, you know, I'll just say one thing on a personal level. That story has driven me all these years because I realized that, my God, we are not asked in our time to give up our lives for this crop diversity. Mm-hmm. We don't have to give up our life for it. Other people have done that. Yeah. We haven't been called upon to do that. So, my gosh, the least we can do is to make sure that this diversity is saved and saved forever and made available to the scientists and the farmers who really need it. And that seems to me to be not as big an ask as Vavilov.
No, it's a field full of, I think, of examples of heroes and acts of heroism that have thought about humanity on a large scale. How do we save the future of food? And there are very few areas in science that touch us all as closely as that. And
yeah, I think it's as your ethnobotanist friends know, it's a field where you can get into it and you can approach the understanding of crop diversity from every angle as a sociologist, an anthropologist, as a geneticist, as a linguist, as even a poet, as an artist. All of those things can be brought to bear and have to be in the end, as well as politics and economics, if you're actually going to understand and do anything meaningful. So you won't get bored.
That's great. That's great. A very fruitful field to definitely do research in the future.
Yeah.
So Cary, for the audience members that might want to learn more about the work of the Crop Trust and other initiatives, are there any resources that you could recommend or websites that they should try and visit, or places they could donate to support these kinds of efforts?
Yeah, I think the best place is to go to the Crop Trust website. So that's croptrust.org, one word, croptrust.org. There are a number of books out there. I've written a few. You mentioned one of them at the beginning. Those are just beginning places. I think that, well, people who want to get their hands dirty and actually get involved in conserving some of this stuff and eating it, by the way, because
yes,
to really conserve it long term, you have to also eat it. It has to have some use. They might want to get involved with an organization called the Seed Savers Exchange, and that website is seedsavers.org. I guess the only other thing I would say is that your senator or your local congressperson will be absolutely shocked to get a letter or postcard from you inquiring about what they've been doing to ensure that our government seed bank is adequately funded and funded forever, and that we're participating with the international seed banks and making sure that they function correctly. They've never gotten such a letter.
It's a good time to start.
When they open it up and receive it, they'll know it's not a form letter or a write-in campaign. Yeah. They'll know some real live human being is actually interested, and they'll learn something when they inquire and try to figure out what the answer is going to be. So surprise your senator or congressperson.
I love that. Great. Well, thank you so much for coming on the show, Cary. This has been enlightening and just amazing to speak with you.
It's been a great pleasure to talk with you. You have a good day. Thank you.
You've been listening to Foodie Pharmacology, the science podcast for the food curious. If you'd like to learn more about the show, visit our website at foodiepharmacology.com. You can also view the full video version of this episode at my YouTube channel, which is at Teach Ethnobotany on YouTube. Stay healthy out there. Thanks for listening, and I'll see you next time.